I think I'm going to be able to do some of my copying and scanning today. Okay. Does everybody agree that x squared times x to the 5th is x to the 7th? Okay? Because when you're multiplying two things that have the same base, what do you do to the exponents? You add them. It is that type of reasoning, whatever, is that type of reasoning. Well, if you add, so if you went x squared plus x to the 5th, those are not like terms, so we can't add them, right? So good question. That helps us to understand this property of logarithms. Notice we can take log base a of a times b and rewrite it as log base a of a plus log base a of b. And the idea is that these are exponents. Logarithms solve for exponents. So when the bases are the same, a and a, just like here, x and x, you add the exponents. You add the exponents, okay? That's what's happening, okay? That's what's happening. So if you're dividing, what do you think you do? So you have log base a of a minus log base a of b. And we'll see if you can think this through. This is log base a of a to the c power. A to the c power means a times a times a times a times a times a. So you're going to have log base a of a plus log base a of a plus dot, dot, dot. How many of those are you going to add up? C of the log base a's of a. So in other words, that would give you c times log base a of a. So you can take the c and move it out front when you have a logarithm, okay, which is kind of cool. Now, when will you use the logarithms? You really won't use them until calculus. They come up in physics, they come up in chemistry, and they come up a lot in calculus. You can see I have a few calculus students who join us right now because they have a test tomorrow and they're a little confused and they need to work. But when they get done with this test tomorrow on Thursday and Friday, they're going to then see some introductions to logarithmic calculus. And when we look at that, logarithms in calculus sometimes can make things really, really easy and really nice. Calculus class, just really quick, the derivative of e to the x happens to be e to the x. The derivative is itself, and that makes things pretty cool. So that's something we'll look at. All right, for everybody else, let's use the laws of logarithms to rewrite the expression in a form with no logarithm of a product, quotient, root, or power. Is this the logarithm of a root, quotient, product, power? What is it? Product. So I rewrite it as log of 5 plus log of 3. Is everybody okay with that? Rewriting it will help us when we get to calculus someday. Now, this is a critical moment. 15 years of teaching this, I had the aha moment today. We'll see if this works for you. Is this the logarithm of a product or a power? Okay, this is what's really important for you to understand as you move forward. We are going to use both the product piece and the power piece, but right now, it is the logarithm of a product. And the reason why is this. When you look at the order of operations, would you take 3 times 4 first, or would you square 4 first? So I would square 4 first and then multiply them. So the last thing we did was multiply. So this is the logarithm of a product. So I will first use that product piece right here, product to sum, in order to divide this up. So I have log of 3, then what? Plus. Awesome. Now, I just have log of 3. Is this the log of a product, quotient, or power? This is the log of a power. I can take that 2 and dump it out in front. I get log of 3 plus 2 log of 4 plus 6 log of 5. Excellent. So what you want to do is you want to do that because on the test I could give you x times y squared times e to the sixth. Okay. All right. Please look at letter C. Is this the logarithm of a product, a quotient, or a power? Logarithm of a power. Why? It's the last thing in order of operations, right? So you have 4 divided by 7, and then you cube it. So I first use the power rule. Now, you guys have to understand, the question is, well, how do I know which one to do first? The quotient or the power piece? And the answer is the power piece. I always struggle to know how to tell students why, and I think that that's the answer. Is it the logarithm of a quotient or the logarithm of a power? And the answer is logarithm of a power. That's where we start. If it doesn't make sense for you, I don't have a whole lot more for you, other than let's just try some things together. So now I have logarithm of a quotient. So what am I going to do? 3 log of 4. Jesse, you did a 3 log of 7. Why not just log of 7? The 3 will distribute. Notice it's 4 to the third power and 7 to the third power, is it not? Now, if you left it like this, 3 times the log of 4 minus the log of 7, that would be fine as well. Does everybody agree that these two expressions are the same? Okay, this is the last time I'm going to kind of try to pound this into your brain, but I want you to pay careful attention to this. Anybody know which one they would give as an answer in the back of the book, the red or the blue? The reason why they would give blue as the answer is it represents the original problem. This one, the one in the red, technically represents log of 4 to the third over 7 to the third. You see how the red represents that one and the blue represents that one? It is in most situations. I am not going to take points off, folks. Either one is absolutely fine. I just want you to understand why they may choose one over the other. They are equivalent in most situations. But without a doubt, there are some interesting times that come up down the road where we may prefer one to the other. Okay? All right? All right. I have log base 3 of x squared minus 5 to what power? Very good, half power. That's what square root is, right? So is this log of a product, quotient, power? What is it? Log of a power. Because it's x squared minus 5, and then at the very end, we raise it to the 1/2 power. So we start by dumping the 1/2 out in front. 1/2 log base 3 of x squared minus 5. Now think hard about this. This is the logarithm of a what? Of a difference. Is it not? We don't have any rule to undo subtraction for a logarithm, do we? We have a rule that says log of a product, log of a quotient, log of a power. We have nothing that says how to undo a difference, so we're done. Yep. You try letter E on your own. Go. See if you can do E. What? What's wrong? You can do it. Don't worry about the ln. The ln is the same thing as log. There's no difference. Okay, here's the answer. Let's look at it step by step and see how you did. First of all, I have the logarithm of a quotient. Agreed? You got to think about your order of operation. That's the only way I know how to think it through. If you plug something into x, you would take it to the fourth. You would then multiply it by 2. Agreed? In the bottom, you would take x, you would subtract 2, and then you would cube it. And at the very end, the last thing that you would do is then divide. So that's why I start off with the quotient to difference rule. You have to think about the last operation you do. So now look at this situation. I have the natural log of 2x to the 4th. Okay? Is this the logarithm of a product or a power? Product, because you would take something to the 4th and then multiply by 2. So because a product is the last thing I did, that's the first thing that I undo. Notice, raise your hand if you dump the 4 out in front. Very common mistake. Now, Justin, is the 2 being taken to the 4th power? No. Is the x. That's why the 4 is only part of the natural log of x. And the 4 is not part of the natural log of 2. Yes, if it was. So, Grace, great question. Suppose you had this. Well, that's not the logarithm of a product. That's the logarithm of a power. Because in that situation, you take 2 times x and then raise it all to the 4th power. You see the difference? Okay? And so that's why we have that discrepancy. Okay? Any other question on that before we go to this last one on the front? All to what power? 1/3 power. Sweet. So do I have the logarithm of a product, a quotient, a power? So what am I going to do first? Dump the 1/3 out front. Now I have the logarithm of a quotient. What? Exactly. And we're going to talk about why that is in just a second here. Okay. All right. Now, okay, let's look at this. Is this the logarithm of a product or an exponent? Product. So I have 1/3 times natural log of 4 plus the natural log of x squared. Then what? Minus natural log of 2 minus natural log of y minus natural log of z. So Jesse told us earlier that we should continue that subtraction. So we're going to do that. And now I have one last step I can do, right? 1/3 natural log of 4 plus 2 natural log of x minus natural log of 2 minus natural log of y minus natural log of z. Now, Gigi had a very good question earlier. Did I miss something? A couple eyes were looking up. Okay. Gigi asked a question about, does it matter, if you reverse the order? And it does. And let me show you how you can check your answer, or at least help verify it a little bit. If I have x squared times y to the -3rd, would everybody agree that that's x squared over y cubed? So you agree that the exponent for the x is positive, but the exponent for the y is negative, correct? Well, look. Is the z in the numerator denominator? So it has a negative exponent then, right? And its value is negative. Y, numerator and denominator? Denominator. So its exponent has a negative value. Negative natural log of y. The 2, numerator, denominator. So it has a negative value as well. But then look at those that are in numerator. X squared. That's in the numerator. So it has a positive value. The 4, numerator, positive value. Okay? And then 1/3. See that? Very good. Flip it over. Let's go the other way. Let's take multiple logarithms and write them so there's just one. Multiple logarithms, just one. Anybody see? Log base 2 of 5 times 7 or 35. I'm going to rewrite this one as 2 log base 5 of 3 minus 1/3 log base 5 of 64. Now, why would I do that? Dividing by 3 is the same as multiplying by 1/3. What can I now do with the numbers out front? I can move them to the so now I have log base 5 of 3 to the second power, which is 9, minus, what is 64 to the 1/3 power? 4. Now I have subtraction. Log base 5 of 9/4. Nope. Jackson, is he rattling you a little bit? Okay, all right. I just, okay, all right. Oh, okay, all right. How about you try C on your own? Go. I believe in you guys. I believe in you, Olivia. I believe in you, Olivia. Okay, let's see what you got. I've got the natural log of 16 minus the natural log of 8 plus the natural log of the root of 2. Now, as I write it from here, I understand that because it's subtraction, it's going to end up in the numerator or denominator. And because it's addition, it'll end up in the, so I have the natural log of 16 roots of 2 over 8, which is the natural log of 2 roots of 2. Okay. That's fine. Okay, that's fine. Okay, now, Olivia, I wrote this problem to try to create that issue for somebody so we would see it. So please watch. Do you agree, Olivia, that I could rewrite this as natural log of 16 plus the natural log of the root of 2 minus the natural log of 8? Do you agree? So my point is that these get multiplied and then this gets divided by. Is that better? Okay, last one, D. Yes, question. Right. Yes. We couldn't do it then either. What we're saying is that if you have the logarithm of a difference, I don't have the logarithm of a difference. I have the difference of two logarithms. This is not log times, this is log of. It would be like saying f of x minus 5, and that you just want to make that f of x minus f of 5. We would never do that, would we? Right, same thing for a logarithm. Okay, I'm going to distribute the 3 through. 3, natural log of x plus 1. Question, sorry. Like this? I would ask that if you can simplify something, please simplify it. Yeah, If you can simplify something, please do it. Because it may end up working out to be something nicer, which we'll see in this next example after we do D. Okay, so I distribute the 3. I get 3 natural log of x plus 1 plus 3 natural log of x plus 2 minus 6 natural log of y. What do we want to do then? Good. So natural log of x plus 1 to the third plus the natural log of x plus 2 to the third minus the natural log of y to the 6th. Now what? What's that? Oh, you don't have to multiply that. You can leave it in factor form. Natural log of what? X plus 1 to the third times x plus 2 to the third. I have addition, so I multiply. I have subtraction, so I divide. Yeah. I don't know how else you would do it. So here's what I look at, okay? Grace. Is it positive? Numerator. Positive? Numerator. Negative? Denominator. Here's what people do on the test, and I will take points off for this. You need to understand that this is not an option. People write the natural log of x plus 1 to the third times x plus 2 to the third all over the natural log of y to the 6th. No, the idea, folks, is that it is a single logarithm. A single logarithm. Okay. Yes. Let's go through some tricky kind of evaluation pieces then. Log base 2 of 32, or the root of 32. I could rewrite this as log base 2 of 32 to the 1/2 power. What do I do? What could I do? Put the 1/2 out front. Very good. 1/2 log base 2 of 32. It's always helpful if you can make a base of 2. Can you make a 32 into a base of 2? 1/2 log base 2, very good, of 2 to the 5th. Yeah, Charlie, what did you notice? Yeah, log base 2 and 2 are inverse operations. Those cancel, and it leaves you with 1/2 times 5. Nope, it's 1/2 times 5. 5/2. This one, log base 5 of. We just do 100 divided by 4, right? So now let's do what we did on the other one. Now let's create a base of 5. Log base 5 of 5 squared. So let's cancel, leaving you with 2. What do you want to do here? Okay, Charlie says bring the 4 out. So we have 4 log base 3. Can you rewrite 27 so it has a base of 3? Good. Yep. Good. How about D? Yeah, e to the 3 natural log of 5. Okay, let's look at what Grace said. This is really, really, really important, okay? So Grace said let's just dump that in front. Now we got to be careful because if I gave you x to the 6, can I just dump the 6 in front and get 6x? I can't. Like those are not the same things, right? So you can only dump that in front if you have a logarithm. So e is not a logarithm, is it? No. Anybody? Okay, so Scott sees that e and natural log will cancel, but the 3's in the way right now. Can I move the 3 up? That's out of the way, isn't it? It's exactly what we did on the other side. Isn't that e to the natural log of 5 to the third? What happens to e to the natural log? And I'm left with 5 to the third, which is? Okay, hey guys, and it's okay. It's okay to sit at a point where you're like, boy, I'm not sure if I really understand that. That's part of what the follow up is, whether we get help or whether we work through in our assignment where we try to understand. Again, I told the company the other day, one of the last professors I had, I said, when he was teaching a statistical theory and probability course for kind of engineers, and it was through a proof based study, and I said, did you understand all of this like when you took the course? He said, no. I said, when did you finally really understand it all? He said, after about the third time I taught it. Because sometimes it's difficult and it's okay. All right. Take out your calculator. You had a question? Because e and natural log, so that's e to the log base e. So that's what natural log is, right? Log base e. Those are inverse operations. Okay, just to make it clear, okay? Log base 10 of 10 to the second. That means 10 to what power is 10 to the second? Think about it. 10 to what power is 10? 2. Those are inverse operations. They cancel, okay? Now, we can also write it the other way. 10 to the log base 10 of 2. Those are inverse operations. We get 2. Okay. Okay. All right. Yo. Yes. Okay, last part, folks. We take out our calculator, and here's the big question we have to answer. This last part is super easy, and it's 3 points for you on the test. Log base 6 of 14, okay? We want to evaluate that. The problem is it's asking us 6 to what power is 14? Anybody want to take a guess? Okay, how about this? Tell me what two integers it's in between. 1 and 2, because 6 to the 1 is, and 6 to the second is, so maybe like 1.3 or something. Well, we're gonna figure it out exactly. It's very challenging to do this without a calculator. You probably don't understand what your calculator is even doing in this process. Well, we can evaluate this. The problem is what's the base of this logarithm? My calculator has a base of, or a base of we can simply evaluate this by what is called a change of base. There's two ways to do it. I'll show you how. You can do the log of 14 divided by the log of 6. What base did I change it to? Or you can do the natural log of 14 over the natural log of 6. What's the base there? It doesn't matter which one you do. I'll show you. Log of 14 divided by the log of 6. Either way, see, I got 1.47. In this one, I do natural log of 14 divided by the natural log of 6, and I get the same thing. You need to write it out to 4 or 6 decimal places. Now, you might be wondering why you need to write it out to 6 decimal places. Here's why. How would I check my answer? I would take 6 and do what? Raise it to the 1.4 power. Is that close to 14? Not really, okay? Exponents are very delicate. 6, we raise it to the 1.47. All right, well, I'm still a ways off, aren't I? I really need to go out to 6 decimal places if I want to get close to the result, okay? And you can see in that situation, now I'm close. So that's why they ask you to go out to 6 decimal places. Yes. Now, that's the first way to do it. The second way to do it is to use your fancy-dancy calculators. Mine is not fancy-dancy, but some of you have this option. So you can see if you have this option, press Math, and scroll down. And when you get to letter A, I don't have that. When you get to letter A, it would say log base. Anybody have that option? Raise your hand if you have log base option. Well, there you can just enter it, right? Okay. Kenzie, you got it? Okay. Now, Kenzie and I are going to race. Are you ready, Kenzie? Kenzie's going to do her math option. You can't press any keys until I say go. Actually, Joe's going to say go at the appropriate time, all right? Can't press any keys. I'm going to do it my way, and you're going to do it your way. Are you ready? So you're going to use the log base option. Are you ready? Joe, whenever you're ready, tell us to go. Done. Okay, so my point is that your calculators do have that option. It's quicker to just do it this way. And it doesn't matter whether you do natural log or log. You can see in this situation, we do come up with 2 point, whoa, I'm sorry. Yeah, you should, I did it incorrectly. Natural log of 2 divided by natural log of 7, my bad. I switched them up. So we get 0.356,207. I got too excited. Sorry about that. And the last one again, log of 1652 divided by log of 14. 2.807723. Okay, 6 decimal places. So using a change of base is important. How's that? Okay. So again, I know that we took up most of the hour, but I want you to know I think it's better for me to take up the whole hour and then give you a whole workday tomorrow, as opposed to go like half the day and half the day and then give you half. So I want to dedicate time to you guys to let you work tomorrow. Here's your assignment. Last year I gave 1 through 55 the odd. I'm not doing that this year. I've switched it to focus the problems. Do 7 through 18, 27 through 34, 40 through 46, and 49 through 52. Understand that some of these, like these are just simply change of base. They should take you about a minute and a half, okay, total. So some of these should be pretty short. So, and again, I'm giving you that time tomorrow. If you show up tomorrow and you haven't even started the first assignment, that's fine, and I'll even help you, but you're behind. It would be excellent if you could show up tomorrow and know the questions that you have, or at least be ready to work on 4.3. So I'll help you with whatever you have, but best to come tomorrow with some things ready to go and work time in place. Questions, calculus.